Now back to what I was saying. We're gonna take the next portion of this presentation very seriously because it's very serious. So, as I was saying, the slope of the table that we have, the points 1, 2, and 2, 4, the slope for that would be 2. So, you would choose one point, so I'm going to choose 1, 2, and I'm going to plug in the x coordinate from that point, which is 1, into the x spot, and the y coordinate, which is 2, into the y spot. So I would have the equation 2 equals 2 times 1 plus b. So, and then I would solve it just like a regular equation. So, the equation would be 2 times 1 gives me 2 plus b equals 2. And then to isolate the b, I would subtract 2 from both sides, and 0 equals b. So, I could just write y equals 2x, and that would still give me the equation of a line from a table. And so now, Mr. Hambright is going to talk to you.
This just in. A man named Jack. Okay, so, Jack, we got him on video talking about how he does not like his salary that much. He works 21 hours a week, and he makes $5 an hour, which sounds pretty good to me, but at the end of the week, he says he gets a bonus of $20. If you add that up, 21 hours, and he makes $5 an hour, 21 times 5 would be, let's see here. I'll just do it out. That way y'all also can try it out if you want. So let's see here. 21 times 5. So 5 times 1 would be 5. 5 times 2 would be 10. So you would have 105. He makes $105 a week, plus that extra $20. So that would make it $125 a week, which sounds pretty good to me. I mean, considering how he works, like, it's not a high up job, it's kind of a lower position, if you know what I mean.
Oh, I understand.
I mean, he doesn't like it as much, so...
Man, I kind of feel bad for Jack.
I know. I mean...
Well, poor Jack. Well, I guess that kind of covers our subject that we were going to cover of creating an equation from real life. So.
Oh, wait a minute. I'm sorry, guys. I forgot to explain what the x and y would be. So the x would obviously be the 5 because that's how much he makes each hour. So you could have any number of hours and you would just multiply that by 5 to get your slope. And the y would be the $20 because that's a bonus. Like, back to what I said yesterday, which y equals mx plus b. So, in this situation, it would be y equals 5x plus 20 because he makes that extra $20 a week. Mr. Shannon, would you like to continue on to the next discussion?
Yeah, no, I think that interruption was very well timed. So,
I'm sorry.
Sorry, he just, sorry, a bird just flew out the window. We're sorry. That kind of got us tickled there. It doesn't happen often.
Just, when they just hit the window.
So, now, I'm going to tell you how to find the rate of change, or slope, from an equation table in a graph. Now, this was kind of similar to what the first thing I was talking about, but it's a little different. It's really not that different. Finding the rate of change from an equation is very simple. All you have to do is identify your m value. So if you have an equation such as, we'll just write it down, such as 2 equals m times 7 plus,
say,
6. What I would do is, that would be, so I would have...
Wait a minute. So this would be the y, where the 2 is, right? The
Correct.
y would be behind it. So, how I do it, not trying to interrupt him, but I would get it and divide first. After I would distribute, and then I would divide both sides by 2, because there's a 2 in front of that y, and you need to isolate that y by itself, like he's about to explain.
So what I was about to say is, we could combine our like terms, such as 7 and 6. That gives you 13. M13 equals 2.
Hold on.
we would divide by 13 on both sides. And 13 divided by 2 is roughly 6.5. So 6.5 would be your slope. So that's how you find it. Or if you have an entire equation given out to you, such as 2 equals 6.5 times 7 plus 6, you would just have to identify your m value, and that would be 6.5, of course. And now on a graph, it's much, much more simpler. So let's say I have the points 3, 6, and
9.
3, 6, and
9, 0.
9, 0. I would count how many times I have to go up first to
explain the rise over run.
It's this thing called rise over run. So you would count how many times you have to go up to get from 3 to 9, which is 6, and how many times you would have to go to get from 6 to 0, which is 6. And so excuse me there.
I'm sorry.
So what you would do
While he
is
keeps explaining, I'm gonna go get us some more coffee. I think we're falling asleep here. Sorry. Go ahead.
okay. So really, all you would have to do is just. It's kind of hard to explain without showing you, but it's really not that hard. It's simply just rise over run. You find 2 points on your line, and then count how many times you have to go up and over to get to from that first point to the second point. So I've covered from an equation and a graph. So let's talk about a table. A table is super easy. It's maybe the same level of easy, or even easier than finding the slope on the graph.
And I'm back. Sorry, guys. We're out of coffee, you know.
Yeah, it's okay.
Jeff, I don't know why he does that.
Yeah, we got it.
I mean, sometimes he just takes the entire pot and drinks it all
Yeah,
by
I need
himself.
you to be quiet. I'm trying to
Sorry, I was just
talk about
explaining
this.
to you. I didn't want
So
you to be mad
then-
that we're out of coffee.
So I'm going to use the same example I did a little bit ago. I have the points 1, 2, and 2, 4. The change in y is 2 and the change in x is 1. Your slope's 2. It's that simple.
Okay.
And now, Mr. Hambright is going to talk to you about interpreting an equation for the y-intercept and the slope.
Okay, so how you would do this is you would think about the original equation, y equals mx plus b. And you would think, which one's the slope and which one's the y-intercept? Which we already explained. The b is the y-intercept and the slope would be the mx. So, depending on what sign your y is, whether it be a plus or minus sign, which is going to be in front of it. If it's a plus sign, it's going to be a positive. If it's a minus sign, it's going to be a negative. So, another example, sorry guys.
He's got some good examples here.
The y equals 5x plus 3.
Hop in the water. Ooh, this is
5x would be the slope, and the 3 would be the y-intercept. It's going to be a positive 3 because it's plus 3. Okay, and I mean, that's pretty much elaborated on. Would you like to discuss the next topic?
I would. And our next and final topic is explaining what makes a relation linear as opposed to another type of function. And again, I explain this a little bit later, kind of getting ahead of myself, but I'm going to go into a little more detail here. So, a function is a set of inputs and a set of outputs. And what makes it a function is that no input can have two different outputs. So 1 can't go to 2 and 4. 1 could go to 2, but then 3 or whatever number it is would have to go to 4. What I can have, though, is 2 different inputs going to the same output, such as 1 going to 2 and 3 going to 2. I could have that, and that would still make it a function. But a linear function is any function that has a rate of change and makes a line on a... If you drew it out on a... If you plotted certain points of the function onto a graph, it would create a line. So, as you can see, we've covered quite a lot today, and we look forward to seeing you next week. So, thank you for joining us, and
this week's Math Facts
Math facts. And
with Mr. Shannon and Aiden Hambright.
thank you.